Hey everyone, welcome back to Islander Robotics. As always, I'm Will, and today what we're going to be doing is we're going to be taking the information we learned from the data pre-processing of TensorFlow's Fashionmans dataset and using it to build a TensorFlow Fashionmans model. Alright, so without any further ado, go find your favorite place to sit back, relax with your favorite snack, and let's get started, shall we? Alright, so as all of you can see on the screen right now, we have three libraries up. TensorFlow, matplotlib, which are two of the libraries that we used in the last video. Also, real quick, while I'm talking about the last video, if you have not seen my last video on data preprocessing of the Fashionmans dataset, go check out that video before you continue on with this video. That will help you understand where we're getting our information with a lot of what we're importing in. Alright, so with that being said, the next library we're going to be talking about is the numpy library. That's not a library that we used in the last video. It is a library that we're going to be using for this video. And with the conjunction of all three of these libraries, it's going to allow us to not only build a model, but also understand what we built, alright? And like also in the last video, I have the data set imported in, as well as the XY values for the train and the test values, alright? As well as the labels needed for all the train labels, alright? So remember that 255 pixel value we were talking about last week, where we had the graph and all that? Well, the reason why we had to get that was because the class images, the train images and the test images right now are set up into integer values. The computer does not like that when it's doing, when it's building a model, alright? It is not going to like the fact that the information is in integer values. It's going to like it more as a float value, alright? And the way we're going to turn that integer value into a float value is just simply by taking train images or test images and dividing it by 255, which is the greatest pixel value, right? And for those of you that need a visual interpretation of what I'm talking about, we're just going to do this. Train images equals train images divided by 255.0, because we wanted a float value, and that is how we take that integer value and turn it into a float value, alright? So we did that with train images. Next we have to do with test images, and it's going to just be test images equals test images divided by 255.0, same exact value as the train images, because as we found in the last video, the highest pixel value for any of the images in the Fashionmans dataset is 255. Now, what are we going to do after this? We're going to actually be building the hidden layers, alright? We're going to be specifying what we want in those hidden layers, alright? Quick, we're going to do model equals tf.keras.sequential. It's going to be a sequential hidden layers. It's going to be a sequential model, alright? So after we specify that, before we can do the hidden layers, we have to take those images from 28 by 28 pixels and convert that into its area, which is 784, and we're going to do that by simply running this command, tf.keras.layers.flatten. We're going to use input shape to input the 28 by 28. Alright, and then, like I said, that's essentially 28 times 28. Next is going to be the first hidden layer, and we're going to be calling the hidden layer by using the dense method. So it looks very similar to the last one, except for flatten, we're going to be using dense. And you're going to be able to see that when I do dense, and we're going to have 128 neurons in this first hidden layer, 128, and we're going to use the activation function relu. All right, activation equals relu. So after using the activation relu for the first hidden layer, next what we're going to do is we're going to do something to prevent overfitting for your model, and we're going to call the dropout method from TensorFlow. And you can just simply do that by tf.keras.layers, same way, except we're going to call dropout 0.2. All right, and I'll explain what the dropout method's going to do when all of you actually have a physical example of this in front of you. All right, which will come later in the video. All right, after calling the dropout method, the dropout, we're going to build the last hidden layer, which is going to be the output hidden layer. So we're going to call it the same exact way we called the first hidden layer, which is tf.layers.dense. The only difference is we're going to be using we're going to have 10 neurons for this layer. Okay, reason being is the reason being is because there's only 10 possible answers for the problem we're trying to solve. What type of shirt, what am I wearing, a shirt or a pullover? All right, that is one of the 10 options that's going to be produced, one of the 10 outputs. All right, and the activation method we're going to call for this hidden layer is going to be the softmax hidden layer. I mean the softmax activation. And that's another one that all of you will understand more clearly as the video continues on and we start making predictions. So activation equals softmax. The next thing we're going to do is we're going to compile the model, and that is just done with the compile method. All right, so you just simply model.compile, and we have to specify which optimizer we want. And for this example, we're going to use the Atom optimizer. All right, equals Atom. And then what we're going to do is we're going to specify the loss method. So loss equals sparse categorical cross entropy. All right, that is the loss function we're going to use. And the last thing we have to specify which metrics we're going to use, which is the accuracy metrics. And like the rest of them, we're going to be calling them accuracy. All right, and then after we specify the compiling, the metrics, the loss, and the optimizer, the next thing we have to do is we have to call the fit method. The fit method is the method you use to train your model. And what you're going to pass into the fit method is your x and your y values. In the circumstance of my program and what I chose to use for the x and the y train values is train image and train labels. All right, as well as what you're also going to pass into the fit method is how many times you want your model to learn. All right, how many times you want it to be taught. All right, and that is the epoch values. So model.fit train images, train labels, and then we're going to say epoches equals 10. All right, after this line, the next thing we're going to do is we want to double check the accuracy of the model, and we're going to use the evaluate method in order to do that. And the way we're going to call the evaluate method is like this: test loss test AC equals model.evaluate. And inside of the evaluate method, we're going to pass in the x and y values of our test values. Right, so for the variable names I chose for my test values, for the x and y test values, is test image and test labels, which is exactly what we're going to pass in. Test images, test labels, and then the verbose we're going to specify is equal to 2. And then how we're going to visualize the accuracy of our model, we're just going to say print the test value times 100 so that we can actually see it as a percentage. Right, so after that, what we're going to do is actually run the code. test times 100. So those red words, ignore. It's just specifying something exactly for my machine. And as you can see on the screen, you're gonna be seeing the epochs. So each time an epoch is running, it is the model learning the necessary data it needs to produce accurate predictions. Each time it runs, 20% of the train image data is going to be dropped, as well as the train labels data is going to be dropped. During the course of my model, it's going to do it 10 times. So 10 times. So during each one of those 10 times, it's going to drop 20% of both the train image as well as the train label, so that it does not overfit. Your model does not overfit. And overfitting is something you want to stay very, very far away from when you're doing anything machine learning, artificial intelligence. You're going to want to stay far, far away from that. And with that being said, let's evaluate our model. And right now we can see that it has an 88.27% accuracy according to when compared to the test images. All right. So what are we going to do from here? Well, the next thing we can do is we can go into the bottom of here and do model.sum and just see what the summary of it is. All right. So we can see the first thing is a flatten, dense. These are all the different hidden layers, right? Essentially, this just gives you a more in-depth understanding of your model. All right. So after that, the next thing we're going to do is we're going to start making predictions. All right. So predictions equals model. We're going to use the predict method to actually start making predictions. MOD predict. And what we're going to pass in is test images. And then after that, we're going to say print predictions 0. All right, we're going to see what is the prediction for the 0 value. All right, so run that again. Of course, you're going to have to go through all the epochs, sit back, relax. All right, so this is where you can see where the softmax is incorporated, all right? So we have, under the first possible outcome, it is 3.064 times 10 times e to the negative 6. All of those, if you add up all those values, it's going to equal 1. The right prediction, the prediction that the softmax is saying that it is going to be the one that's closest to 1, all right? Now, how do I actually call that? How do I actually see that without seeing all of this information? Well, that's where numpy comes in. And we're going to use print numpy np.argmax predictions zero. All right, now run it again. Well, we could run it again, but what I'm going to do now, if you run it again, you'll see exactly what I'm talking about. As you can see on the top, you can see the prediction values without the NP argmax, right? NumPy argmax. And underneath, you can see which one is the closest to 1, which is the prediction that softmax is specifying is the correct answer, which is 9. All right, so 9's great, but what is 9? Well, we can do this one of two ways, all right? And I'm going to show you both of them. First way we're going to do it is just by typing in this code. While true, input. We're going to say input what equals input at what would you like to continue? All right, this is how we're going to break the while loop, so that's why I just put that. If what equals yes. Then we're going to say input I equals input of what value would you like to predict? And then we're going to say print class names np dot arg max predictions 0, else break. And now run the code again. We're going to say yes. And then what value would we like to predict? Well, let's plug in the one that we did for the last one. 0. It is an ankle boot. Would I like to continue? Why don't we try one more? Yes. Let's put in 1. Make a prediction of 1. Okay, 1 apparently is also an ankle boot too. But words are fun and all, but let's actually see if we can actually see the images that are being predicted. And to actually visualize the data that is being produced by the predictions, we're going to just copy and paste these 2 functions that I have on hand. And then after those are copied, the next thing we're going to do is we're going to create something very similar to the last while loop with while true. We're going to say what equals input should I make a prediction? We're going to just simply say if what equals yes, then it's going to go on to the prediction part of the array, which we're going to say I equals input what is the value you would like to predict, and we're going to say print class names comma np dot arg max. And then we're going to say predictions at value I. And now just to make it a little bit cooler, we're going to add one more part to this. We're going to say next equals next equals input. Oh wait, real quick, I almost forgot. So the value of, I'm going to get back to this input. So the value I actually has to be an integer value. What the input, by using the input method, we're going to be producing a string value. Alright, so just the way to switch that around is just by doing this. Oh, no, not there. Int input, and then come over here and close it up. That's all you really have to do. Now back to this input. Sorry about that, a little sidetrack. Input should I make the data into a picture? Let's just say picture. If next equals yes, I'm going to say plt dot figure and then fig size equal what don't you like? We're going to say plt dot figure and then we're going to pass into the figure fig size. Fig, and then underneath size, we're going to say 6 by 3. Alright? Next, we're going to say plt dot subplot. We're going to use a subplot. Go down here. And we're gonna just say 1 by 2 by 1. Alright? And the next thing we're gonna do is plot. We're gonna call one of the functions I copy and paste into it, and we're gonna pass in I, the value of predictions, at I, and then test labels and test images. Alright, plt dot subplot again, and we're going to do 1 comma 2 comma 2. Alright, and then we're going to say plot value array, and we're going to pass in I, the value prediction at I, as well as the test labels. So I, comma, predictions at I, comma, test images, and then we're going to say plt dot show, and then to just make a just so that the if statement is balanced, just going to say else pass, and then one more, we're going to break the while loop, we're going to say else break. And then after that, we're going to run this, and so you guys don't have to sit through all those epochs again. I'm going to fast forward it. So I'll see you guys in a couple of seconds. Alright, so now that the data has ran, my computer's asking me, should I make a prediction? We're going to go with yes. Alright, so yes, and then what's the value? Let's put 0, because that's what, again, that's what we've been doing all night. So 0. Ankle boot, all our predictions have been saying ankle boot, so that is no surprise to me that it's saying ankle boot. Now, should I make the data into a picture, or should I make the data visualize? Let's just say yes. And here it is. This is the data when the graph makes it visualize. And in all honesty, I'm very impressed with the data that is being produced, as well as this shows exactly how softmax works. And softmax is basically, so when you use a hidden layer that's used in softmax, it's going to break the data up into like how this graph is showing, where you have essentially 7 has a certain value to it, 5 has a little bit of a value, and 9 has a value of it, which we know 9 is ankle boot, which translates so that when you add all these up, it's going to equal 1. So the values that you have in that blue bar is going to equal 90, it's going to be 0.9, it's going to be 0.9, alright? And then the other ones are going to equal it's going to equal the rest of that 1, alright? So it's going to equal the rest of that 100%. In the case of softmax, it's going to equal, all 3 of those together are going to equal 1, alright? So with that being said, let's try another let's visualize another one, alright? So should I make another prediction? Let's say yes. And what should I make a prediction of? Let's go with lucky number 6. And it's predicting a coat. Should I see the data? Should I visualize the data? Let's say yes. And 97% coat, and again, it is splitting the data up into like how I was stating before, alright? With three different values it could possibly be, and then while all at the same time equaling 1, alright? And with that being said, I'm going to say no. I put down no because that's all I have for all of you this week. As always, the code that I use for today's video will be down in the description bar down below, as well as if you have any questions in regards to my code, please leave them down in the comment section down below. I'll be glad to answer any comments or questions that any of you have. If you learned something from this video, as well as if you enjoyed this video, please consider hitting that like button, and if you're not yet subscribed, please consider hitting that subscribe button, as well as that bell icon, so you can get notified when I post my next video about Python, TensorFlow, 3D printing, as well as my personal project, Wolfy the Artificial Intelligent Dog, which will be back onto the channel as soon as I finish 3D printing all of his parts. Until next time, happy coding, guys. Bye!